Lesson 5. Solved Problems Part 1. Examples. Number 6. A binary operation asterisk is defined on the set arrow of real numbers by a asterisk b equal to a plus b minus 2ab. A, B are members of arrow. Roman figure 1 is the operation asterisk closed under the set arrow. Give a reason for your answer. Roman figure 2, find the identity element of arrow under the operation asterisk. Roman figure 3, determine the inverse element under the operation asterisk of a general element A member of arrow, stating which element has no inverse. Solution. This is the given operation. The operation asterisk is closed on the set arrow because A asterisk B is a member of arrow. Then A plus B minus 2A is also a member of arrow. Take, for instance, let's assume A to be 2, B to be 3. So 2 asterisk 3 simply means 2 plus 3 minus 2 times 2 times 3. That is coming here now. 2. A is 2. B is 3. You have 5 minus 12 equal to minus 7. If 2 asterisk 3 is a member of the set arrow, then minus 7, the result, is also a member of arrow. Hence, there is closure. Roman figure 2, let the identity element be E. You have this result. In the given operation, you replace B with A. You replace B with E. Replace B with E. A remains the same. So you have A plus E equal to minus 2AE. Then you equate A to A. Collect like terms. You have this result. From here, factor out E. You have E bracket open 1 minus 2A bracket close equal to 0. Divide through by the coefficient of E. E becomes 0. Roman figure 3, the inverse of A is A inverse, written in this form. The condition for inverse is A asterisk A inverse is equal to identity element, and that element is 0 from the previous solution. So you have this as equation 1. To proceed, you have to replace B with A inverse in the defined operation this. If you replace B with A inverse, you have this result. That is equation 2. You have to equate equations 2 and 1 because the left hand side are equal. By implication, the other sides are also equal. So you have it in this form. Transfer this term to the right hand side. You are left with this. You factor out A inverse from the left hand side. You have it in this form. Divide both sides by 1 minus 2A to get A inverse in this form. The element without inverse is 1 over 2. If you put 1 over 2 in place of a, you have 2 times 1 over 2. That is 0. That is 1. 2 times 1 over 2 is 1. 1 minus 1 is 0. Is 0. So 1 over 2 has no inverse. Example 7. A binary operation subtraction defined on the set of real numbers is such that S, the subtraction operation y, equal to sy over 6 for all sy members of arrow. Find the inverse of 20 under the operation when the identity element is 6. So no need solving for the element again. All right, but we need the inverse of the element. Let the element be s. So the inverse of s is this. The condition for inverse is s, the given operation S inverse is equal to identity element. In this case, E is equal to 6. Let's call that equation 1. To proceed, you have to replace y with S inverse in the given operation. This is the given operation. You replace y with S inverse in this form. Let's call that equation 2. You have to equate both equations since they have the same left hand side. By implication, the right hand sides are also equal. So you equate them. Multiply through by 6 to clear fraction. Divide both sides by s to get s inverse. The inverse of 20 simply means replace s by 20. So 20 inverse is equal to 36 over s. That is over 20. When you reduce, you have 9 over 5 as the inverse of 20 under the given operation. Example 8. The multiplication table above has modulo 10 on the set S equal to these elements. Find the inverse of 2. Solution. Let me explain the results in the table. First, in modular arithmetic, we are interested in the remainder. Secondly, modulo 10 has 10 elements, 0 to 9. So any outcome that is 10 and above is divided by the modulo 10, then you record the remainder. You can take it row wise or column wise. Let's check the elements here. We use 2 to multiply each element in the column. 2 times 2 is 4. 2 times 4 is 8. 2 times 6 is 12. But here is 2. 12 is not an element in modulo 10. And as such, you divide 12 by 10. You have 1 remainder 2. You record the remainder. 2 times 8 is 16. 16 is not an element in modulo 10. You divide it by 10. You have 1 remainder 6. So you have 6 here and so on. We are interested in the inverse of 2. We are to use either row 2 or column 2 to get the inverse of 2. Solution: 2 times inverse of 2 is equal to E, the identity element. First, we have to find the identity element on the row of 2. On the row of 2. From here, we have 2 times E equal to 2. You multiply 2 by E, you have 2. Why is this so? Remember, in our previous lesson, we have it that A asterisk E equal to what? A. So A is 2 now. So we have 2 times E equal to 2. The question is, from row 2, which number will 2 multiply to give you the result 2? Result 2 is already here. If 2 is the row, then 2 times 6 is equal to 2. That means E is equal to 6. Hence, 6 is the identity element. Next, we are to find the inverse element on the row of 2. We come back here. 2 times inverse of 2 is equal to E. Now E is equal to 6. The result is already 6. You have 2 in the row. So which number will 2 multiply for you to have the result of 6? That number is 8. 2 times 8 is equal to 6. That means the inverse of 2 is 8. Also, from that row 2, 2 times 8 is equal to 6. Hence, the inverse of 2 is equal to 8. Example 9. In the table above, find the inverse of 4. Solution: let us use column wise. Before that, let's try to get the modulo used in this table. Let's check the element 1 against the elements in the column. 1 times 1, 1. 1 times 2, 2. 1 times 3, 3. 1 times 4, 4. Let's try the second element. 2 times 1, 2. 2 times 2, 4. 2 times 3, 6. And here is 1. That means 6 divided by 5 is 1 remainder 1. So the modulo 5 is used in constructing this table. 4 times inverse of 4 is equal to E. Find the element E on the column 4. This is column 4. Remember the condition. The element 4 times E is equal to 4. That is 4 asterisk E is equal to 4. Here the operation asterisk is based on multiplication. So you have 4 times E equal to 4. 4 is the result on column 4. This is column 4. Result 4 is here. So which number will 4 multiply in order to get 4? That is 1. 1 times 4, or 4 times 1 is equal to 4. That means E is equal to 1. Hence, the identity element is 1. Next, we are to find the inverse element on the column of 4. You come back here. 4 times inverse of 4 is equal to E. E is already 1. So 4 times inverse of 4 is equal to 1. From that column 4, the result is already 1. So 4 times what that will give you 1? It is 4 times 4 equal to 1. So 4 times 4 equal to 1. Hence, the inverse of 4 is equal to 4. End of lesson 5.